what we started with specifically here is a source to target comparison. We compared a source and we compared a target, and here there was just a select star query as such. Now, what we want to see is how the application creates for transformation use cases. Cases like these, where there are multiple tables that come in together and create a singular table. Now, what I'm going to show is how the application does this, say, from a microscopic perspective, but I'm also going to try to show how we can do it in bulk. So that's what we're going to start with. So let's open up our test case. And I'm going to work with our, say this is staging versus Mart layer. So let's say this is staging layer, stage layer. And I'm going to go to Jaffle shop. That's the connection I'm working with. And I'm going to work with my staging layer. All right. So now, what do I want? I want to recreate this particular table called M orders. Now, it's kind of important for me to know how these tables are generated. So instead of creating all the columns as such, what I want to do is create, say, a data set which has customer ID, order ID, and maybe a column which has, say, 3 columns together. All right. Is food order or is drink order? So you want to just make sure if that's the case. So if that's the case, here's what I'm going to do. I want to see every order and for customers, every order and customer. I want to see for every order and customer if the order was of food items only, drink items only, or drink items only. Flags 1 and 0. So what have I done here? Well, I've done basically what you might find in a mapping document, and that's where we are headed. What we have done is we have defined what you're expecting from this particular system as a whole. And since this is an AI system that's running in the background, you can actually ask it to create the queries for you. And as you'll see, we have actually combined our systems from multiple things and see if the actual systems match. So again, I can preview this and I can check if the particular system is correct. And if something like this happens, well, as expected and as you think, you can just provide it the error and it's going to fix it. It's basically your very own ChatGPT system, but it's not actually connected to, say, Azure OpenAI or OpenAI. This embedded LLM can run within your infrastructure itself. So that's one of the key use cases here, that you can actually use this application to decide how exactly these things are working on. So as you can see, this is actually creating a particular system, order ID, customer ID, food items only, drink items only. And it has actually created a proper query joining the 3 tables that we were expecting. Let's run this. And this is the transformations that were in our staging layer. What do you want to do with this? Now that we have combined, say, we've even applied some transformations here, and we have combined 3 tables in staging, we want to compare that against its counterpart in the Mart layer. So let's look into that particular example. My staging layer is loaded. Let's add our Mart layer. Go to JDBC. Let's call this Mart layer. Now I'm going to connect to my Mart layer system, and I'm just going to say I want customer, order ID, and flags for food item and drink item. This should be a fairly straightforward query, but you'll see that I'm not specifying from which table and other systems here. It shows the power of AI as a whole, because we are basically telling the AI what I want in plain text. And the reason it can understand what these queries are, what these column names are, is because the application has something called as a RAG that runs on the data model, that picks up a bit of sample records and even creates descriptions for them. So let's kind of double down on that, on exactly what's happening. You see, when I go to, say, a Mart layer system, here the tables have associated descriptions between them. So if I go to columns, these descriptions are actually generated by the AI system. And so it understands what the context situation here is, what the relations between tables are, and other aspects as well. And it uses these relations to work with joining keys to understand what I say in plain text. Of course, it can integrate with Collabra, Unity Catalog, and other systems as well. But the key aspect is that this is exactly what I have done. I've provided plain text requests, and it has given me expected values. And again, as we see here, We're working with ones and zeros, I presume. There we go. So it's customer name. Now, again, I think I was working with customer ID. So let me fix it. I want customer ID, not name. So it should fix up the query and I should be good to go at this point. There we go. So customer ID is present. I can check if this particular query is in fact valid. And now let's run this. So what have we done? What we have done is that we have compared source against target. But at this point, we had made sure that we are working with the transform values. We're working with columns from multiple systems. All right. So I think there's going to be a good amount of, say, mismatches here. Is what we are expecting. So now this is data compare, but technically it's ETL validation we have done here. And we've done this using a bit of white box testing. So again, that's just a bit of fancy terms there to illustrate what we have done. All right, let's pick up stage. Let's pick up Mart, column-wise mismatches as we have done in the past. And here, let's remap them by name so that the correct things are being placed against another. And let's click on the results. So one key thing, you'll see that we are working with integers and strings. So of course, I don't really have to change this. The application is going to handle this inherently. And so let's click run and let's see how many mismatches we are dealing with. So again, we're expecting a high number of mismatch in this particular live test case because we want to illustrate the mismatches, but we'll see what the data sets actually come into. Once again, this data compare can scale up to billions of records as well. So that's one key thing to look into. And nice, we have actually found specific use cases here. Firstly, if you look at the staging layer, most of the transformations are valid. So we're looking at pretty good validation use cases. There's about 20% mismatches. The real problems lie in the Mart layer, which is riddled with issues. There are multiple issues. The first one is that, well, there are mismatches. Some drink-only items aren't really matching as expected. So there is some issue within these use cases. Bigger problem. There are some records and there are some customers which are present only in the Mart layer, which are somehow absent in the staging layer, implying that we might have missed some, another source or systems or something like that. So we have some issues here. And another issue which might not be terribly important for specific use cases, but here we see there are duplicates as well that we have defined against order ID and customer ID. And so the application is calling those out. Here there are duplicates within our expected system as well. So in a nutshell, what we have done is that we have done a bit of ETL transformation. And if you can finish up this example, what basically happens in an end use case scenario is that this is done for the entire table altogether.
For further questions, feel free to reach contact@datagaps.com. Request a free demo, scan the QR code below. Thank you.